Hello, pre-calculus student. This video is for chapter 4.5, log properties. The more advanced one where we use our log properties to expand log expressions. So in the last video, we talked about how we can use the 3 log rules to expand or condense log expression. When you have 2 log expression add together, you can condense them into multiplying inside 1 log. But you have 2 subtracting each other, you can condense it into dividing. And if you have a coefficient multiply outside, you can condense as a power, and vice versa. If it is inside, you want to expand it, you can expand it this way. So these are the 3 rules. We use it individually in the last video, but we're going to use all of them together. So some basic things I want to mention is rewriting root. So if someone write x square root x, you can rewrite it in another way, but you can rewrite it as x to the power 1/2, right? A cube root in exponent is defined as x to the 1/3. And all in all, if I have x to the n, that is divided as x to the 1n. Another thing is if I have x over y and I wanted to divide it by z, so how do I do? It will be x over y, kind of like divided by z like that, right? So if you see this kind of thing is x over y times 1 over z, that is equal to x over yz. So if you have a fraction divided by another expression, this expression actually go in the denominator. So these are some of the prerequisite algebra skill that we need to review. So when we have an expression like this, there is an exponent, there is multiplying, and there is dividing. How do I expand them? Which one go first? So most of the time we would do a quotient first. In the notes I say product and quotient. That seems like you do quotient first, but actually it's quotient first. And then you do products, and then you do power and root after rewriting. Okay, so after rewrite. So after you rewrite as 1 over something or exponent of something. Okay, so let's do this. Log 3, log base, log, I think it's base 10, x cubed y. So this is multiplying as a root. Then there is a exponent, z for, there is a big dividing over here, so I'll bracket them. So as if you are doing log a fraction. So expand by quotient first. So the top would all together minus log z4, right? Now you look at individually, you say, okay, so this is a multiplication. I'm going to expand it as log y, x cubed plus log y, and then minus log z to the power 4. Now the last is for power. So these are all good powers. This is power 1. I don't have to do anything. So this would move the front as coefficient by the power rule. Okay, so the second is log square root x. So I'm going to change this into log square root x over y times z. So to make it just more interesting, because I don't have an example where I have 2 things in the denominator. So what should we do? So we would say expand the quotient, right? As if they have a parenthesis. So become, let's do the rewrite first, right? So rewrite the root. So I see a rewrite. Well, I can expand first, and then after that we do a rewrite. Minus log, so the whole thing, say don't y times z. Okay, this is not subtraction, but like a subtraction. It's a multiplication, yz. Okay, so now I'm going to split it by rewriting it as log x to the 1/2. Rewrite it to power 1/2 because it look like minus. What about this? This is multiplying, so I can split it as add. But before you do that, please bracket it, because this is 1 log. If you are expanding, you have 2 expressions inside it is a add, but it is under a bracket. Now you can move the 1/2 out, 1/2 log x. You distribute the negative in, minus log y, minus log z. So if you have two things in the fraction, so that's what you do. C, expand log cube x square. So there's no dividing, there's no multiplying, it's just this. So I'm going to just do ln rewriting x 2 but 1/3, right? Now when you have log AB, mn, you can multiply them. That's actually x 2/3. Okay, 2 times 1/3 is 2/3. Then move to the front, 2/3 ln x. That's it. Oh, this one is a lot, right? So I'm going to just do the fraction. So that was equal to log 6. 64 x cubed for x plus 1 minus log 2x minus 1, right? So this is a quotient. And then I look at this, there's a lot of multiplying. So I'm going to do log 64 plus log x cubed. Technically, I should bracket it, but this is just a multiplication, is not dividing, so I don't need to. Plus log 6, oh, I should say log base 6, log base 6. 4x plus 1, and then log base 6, 2x minus 1, and that's it. So no more. Okay, so there's an exponent. I move it to the front first also. Log base 6, 64 plus 3, log base 6, x plus the last two. I do not change them. Why? Can I move the 4 out? No, because it's a term in 4x plus 1. Whenever you have term, you log in. Log base 6, log base 6, log base. Oh, no, this is a subtract. The last one is a subtract. It was from a dividing, so it's always a subtract. Subtract log base 6, 2x minus 1, and we're done. D, oh, this should be E. Can we expand log x squared plus y squared? Can I say is 2x plus 2y? No. These are terms, so no more. You can expand it if you can factor it, but x squared plus y squared has no factor. The only things you can do is if this is a minus, you can factor them, then you can break it up. Okay, so maybe I'll put another one here. What about, can we expand log x? Have to add this equation, x squared minus y squared. But now this one I can. So the first E is no, right? So this one is a no. This one is no because these are not products, right? They are terms. But this I can. And yes, why? Because I can factor them as product. X plus y, x minus y. As a matter of fact, this shows up quite a bit in calculus, so I want to talk about it. So I have x plus y times x minus y. So x plus y plus x minus y. Okay, so be aware of terms. You can only do it if you can factor it. So that's why for x plus 1, I can factor it. They are just one expression, one product, so cannot. Some results of this, or okay, so how do we condense? How to? Okay, so this is condense, an example of condense. Using all of them together. The easier way is just do all the power first. So when we do rewrite, we do the what first? We do the power and root last, but now we do the power and root first. And then we do from left to right. Okay. Apply quotient rule last. Well, I would say apply quotient and product rule from left to right. Quotient and product rule from left to right. Yeah, I think I would change it like this. So let's look at this. So first scan if there's coefficient. Coefficient. So we write it as log x minus log y cubed minus as log z 1/3. Z 1/3 is root, right? Subtract means log x over y cubed, and then log z log log not base z log z cube root. Another subtract means I have to do dividing, and we know x over y cube divides cube root of z. Maybe I'll just do more space. Because this looks a little funny. Okay, so I talk about if I have things dividing of fractions, right? So this is log x over cube over z cube. So that is equal to log x over y cube z cube over here. So that is the final answer. Yeah, that's what I mentioned earlier in the beginning. If you have x over y divided by z is x over y times 1z, so x over y z. So the second negative goes in the denominator also. And then we have, this is easier, it's all add, so there's no divide. But first move the exponent inside, so be log x plus log y squared plus log z to the 5. So that means it's log x y squared plus log z5, and then all of them x y squared z5, like that. Here I have a add and a subtract. So the rule is to follow from left to right. Okay, so move inside first. So the first is 2x squared. The second will be 1/2 log 2x minus 1 to the power 1/2. So don't distribute. It's the whole thing x minus 1 1/2 minus log. This is the end. It's a minus log 2x plus 3 square first, and then to the power 3. So let's rewrite them nicer. 2x squared plus the log base 2 square root of x minus 1 minus log 2. Let's simplify this. 2 times 3 is x plus 3 to the power 6. Add is multiplying x squared square root of x minus 1 minus log base 2 x plus 3 to the power 6. Okay, so now I am subtracting, so it will be all these things in the top, and the whole thing is in the denominator. And that's the final answer. The last information is about change of base formula and one-to-one properties of logs. So because we're heading into chapter 4.6, which is solve log equations. So if I have a log of something, same base equal to log of something, we can basically cancel this by saying, I'm going to do b power. So b and log cancel is equal to m equal to n. Okay, so that's how you can free up things from inside a log. The second things we want to talk about is change of base formula. So in case I have a log base b, x, and I want to put it in the calculator. For example, I have a log 5 23, what is it equal to? In the formula, in the calculator, I only have log base 10 to use, and ln, I don't have log base 5. So what do? I think some newer calculator have, but there is a change of base formula that you can use, which is, if you see things like that, you would say, okay, let log base b x is equal to y. And then we can rewrite it. So the rewriting is b to the y is equal to x, right? B to the y equal to x. So I'm going to apply log 10 to it. So log 10 b to the y would equal to log 10 x. So this is the equivalent equation. So you have two things equal. You apply log base 10. Then you move y outside. So y log base b is equal to log base 10x divided by both sides. So it's log base x over log base b. So I start off with this. This is equal to y. This is also equal to y. So log base bx is equal to log 10x over log 10b. And the same for ln. So if you want to do log base 523 in the denominator, what you can do is just do log 1023 divided by log 105. You will get the answer. Okay. 11. Evaluate log 5 100. So I would do log 10 100 over log 10 5. Round to 4 decimal place. So put in the decimal calculator. Oh, free up some space first. Log base 10 100, that's 2 over log 5. 2.8614. Log 210, what is it? Will be log 10. We can do ln, okay? ln 10, ln 2. So the base, put in the ln 10, ln 2, ln 10, ln 2. 3.3219. Okay, so that's this second part of chapter 4.5.